talk about evaluating composites of trig functions. So what that is, it's a function within a function. So sometimes you can take the tangent of an inverse tangent or something like that, or the sine of an inverse sine, or the, I'll just give you a bunch of examples. So if I have the tangent, where did I start? We're starting with a toughie. That's okay. What if I say find the tangent of arc cosine of 2/3? Well, would you know how to do that? Without your calculator, by drawing a picture. The exact value without a calculator.
Use a textbook.
You can use a textbook. No, then you can't call a friend either. All right, so what you want to do is draw a picture for most of these. So arc cosine is positive in the first quadrant. So you draw a picture there in the first quadrant, and you make a right triangle. And you call this side 2, and that side 3, right? And then you do the Pythagorean theorem to find this side over there. So what's this side over here? Do that. 9 minus 2, what would it be? Very good. Square root of 5. Very good, Jackson. Square root of 5. So what is this? So this says there is some angle whose cosine is 2/3. Adjacent over hypotenuse is 2/3. What is the tangent of that angle? So what's the tangent of that angle? Root of 5/2. So that's equal to root of 5/2, and then you're done. Yep. That's all. Yes, sir.
Isn't cosine positive in the fourth quadrant also?
Yes, but arc cosine, very good question. Arc cosine is only defined to be positive in the first quadrant.
Okay.
Remember when we restricted the range of those so that you can only have one answer for inverse, and that's why. So that's kind of what this whole section deals with. Yes, ma'am.
Can you graph these?
Can you graph?
These compositions?
Yeah, you could graph them. I'm not sure what they look like, so you could graph them. And I don't think that would. You could plug that into your calculator and get the same answer, root of 5, but it wouldn't be an exact answer. You could graph
No, I
them.
was just wondering, like, if you threw an X in there, set 2 digits, like, what would
Yes. What would it look like?
Yeah.
What is
I don't know. I don't know.
no vowel mean?
What? No value?
That's what it says. Then no value.
Is that what you did that for this one?
No, I did it for graph.
Oh. Did you put an X in there?
Yeah.
Arc cosine tangent of arc cosine of X. Arc cosine of X. I don't know. I have to think about it. Don't ask me questions. Just let me finish, okay? Then I'll answer those questions. You guys are exploring too much. All right. So let's do cosine of arc sine of -3/5. So here's where you have to think about what are the domains of the inverses, okay? So say I were to be asked what's the cosine of arc sine, which means inverse sine, arc sine of -3/5. Alright? So like this. So then you have to draw another picture, and you have to think about which quadrant you need to be in. Which quadrant is arc sine, inverse sine, negative in? Remember I told you that yesterday? Which one? 4. Okay? So you have to look between pi/2 and between pi/2 or -pi/2. So you look over here and you do the same thing. You draw a picture, but the hypotenuse is always positive. So you call this side 5 and you call this side -3. Right? And then you do the Pythagorean theorem. What's this side going to come out to be? This is a Pythagorean triple. This side comes out to be 4. So, and it's positive, right? So it's useful to put this one's negative, this one's positive, because cosine is going in the positive direction. So what's this answer? Hello? 4/5. Okay, 4/5. Because it says there's some angle, theta, whose sine is negative 3/5. Yeah, you could go and figure out what that angle is, but you want the cosine ratio of that angle, right? So you don't actually want to compute what that angle is. You just want to do it by drawing a picture, because you don't want to have to use your calculator, because that angle comes out to be not an exact angle, right? Because it's not one of the ones on the unit circle. Okay? So that's how you do that. And then they do so. Oh, and then sometimes, and in calculus, what we're doing, sometimes you'll have something like this. Sine. Find an expression. Find an expression for cosine. Wait, where is it? Sine of arc cosine. Sine of arc. Sine of arc cosine of 3x. And they do give you a restriction. They said x has to be greater than or equal to 0 or less than or equal to 1/3. Okay? And they put a restriction on the domain. Why do I have to put that restriction on there? What's the biggest cosine to be? 1, right? So if I plug in 1/3 here, right, it's going to give me out 1. So if this were anything bigger than 1/3, then I'm going to get an error. If I try to take the inverse cosine of a number bigger than 1 or less than -1, then I would get an error in my calculator. So what you do the same thing, okay? And the reason they're teaching you this, to say what good does this do? When you get to calculus, you're going to want to find derivatives of stuff like that, which means the rate of change of things of that particular function. And you're going to have to draw a picture like this to find the rate of change. So it's kind of like a genuine pre-calculus idea. So arc cosine is and x is positive. So which quadrant do I have to be in? Where is inverse cosine positive? First quadrant. So I draw a triangle on the first quadrant. Okay, and I call this side 3x, and I call this side 1. Is that right? You want the angle whose cosine is 3x. So in order for this, do you understand? Adjacent over hypotenuse would be 3x. Yeah? No? So I put a 1 over there. So using the Pythagorean theorem, this side comes out to be, you're going to do 1 squared equals 3x quantity squared, right? Plus, we'll call this side b. But we'll call it b squared, right? Pythagorean theorem. So what's 3x squared? 9x squared plus b squared. So b squared equals 1 minus 9x squared. So b is equal to plus or minus the square root of 1 minus 9x squared. But in this case, I just need to worry about the positive 1 because I'm in the first quadrant, and this length is a positive number up there. Do you understand that? Why it's positive and not negative? And then I'm not done yet. What is the sine of this angle? We'll call it theta right here. So this is theta. It's some angle whose arc cosine is 3x. What's the sine of that angle?
Square root of 1.
Right? Square root of 1 over the square root of 1 minus 9x squared. So when you get to calculus, they'll ask you what is the derivative of the inverse of sine, which means what's the rate of change of that curve. And then, did I mess up?
Yeah.
Yep, I messed up, sorry. It should be, you got me. It should just be 1 minus square root of 1 minus 9x squared, right? So it would just be equals this opposite over hypotenuse, which is just square root of 1 minus 9x squared, right? Okay? So a lot of times when you get to calculus, they'll say, what is the derivative of inverse sine of this or arc sine of this, and then you have to draw this triangle and find out those sides. And it doesn't come out to a trig function, it comes out to something with x's and y's in it. And that's where they get it from. And that's why they're teaching you this here. All right? Okay, Mason? Okay. All right. Not too much more. Hey. What? I've only inverse some more composite functions. And these ones we're going to bump it up a notch here. Okay? So you have to think a little bit. Inverse sine of 5 pi over 6. Whoa. And this is where you really have to think about your unit circle and the domain and the range and stuff or the range of the inverse trig functions. All right? So where is 5 pi over 6 from your... no, it's not in the fourth. It's the second. It's in the second quadrant. Okay. So this is 5 pi over 6, right? 5 pi over 6, which makes this angle here pi over 6. What is the sine of this angle? What is the sine of this angle? 1/2, right? Positive 1/2, right?
How'd you know not to put it in the first quadrant?
Because the angle that you're taking the inverse of is 5 pi over 6. 5 pi over 6 is in the second quadrant. Okay? But you want the inverse sine. So what this says, this quantity is equal to 1/2. This quantity equals 1/2. And so what is the inverse sine, this is asking you, of 1/2?
2.
No, That's, you're thinking reciprocal. What is the angle? Very nice, okay? What is the angle whose sine is 1/2? And you can't say 5 pi over 6 because inverse sine is only defined here or here, you see? So you have to bounce back to this quadrant, okay, where inverse sine is also 1/2, right? And so this angle right here, just like Henry said, is pi over 6 radians. So the answer to this question is pi over 6. And these ones you can't really do without drawing a picture and using the unit circle. You understand what I did? Okay. You have to think about the range of the inverse function. So one way to think about it is, what is the sine of this angle? What is the inverse sine of that number? All right. So let's do another one. Who's wrestling? Stop eating paper. Are you okay? That's probably why you're falling sick. Probably have brain damage from eating plastic. All right. Inverse cosine of cosine. Inverse cosine of cosine of 7 pi over 4. Okay? So, no, that's, someone find it. So again, do the same idea. Where is 7 pi over 4?
Fourth quadrant.
In the fourth quadrant. So I'm going to come over here and draw a picture. That's when this angle, the reference angle here is 45 degrees. Okay? What is the x coordinator? What is the cosine at this point? Square root of 2 over 2, comma, negative square root of 2 over 2. Okay? So what angle has a cosine of root of 2 over 2? But remember, inverse cosine is only defined in quadrants 1 and 2. So where else, what this says, is where else is cosine equal to root of 2 over 2 in either this quadrant or this quadrant? Pi over 4. Very good. Okay? So that answer is equal to pi over 4. Do you follow how you kind of think about that? Okay? Here's a you try. See if you can come up with the right answer. I'll give you a valuable participation point. Okay? You try. this is a tricky one. Inverse tangent of cosine. Let's see, that's right here. Of cosine of pi. Okay? Inverse tangent of cosine of pi. Let's see who can come up with the I have thousands of viewers out there waiting for my answer. Okay? So what's the cosine of pi? -1, right? So, right? Cosine of pi is -1. Where is inverse tangent negative? Where is inverse tangent negative? Which quadrant? In the fourth quadrant. Remember I said yesterday, for inverse tangent you have to look in the first quadrant or the fourth quadrant. What is the angle whose inverse tangent is -1?
45
Negative 45 degrees. Okay?
Oh.
Negative 45 degrees or negative pi over 4. Okay? You get that? Okay, so that's tricky, right? Tricky. But they're short, but you have to think, right? And you have to know where those inverse trig functions are undefined. Okay? Then I'm going to do 2 more problems, and then I'm going to set you free to work. All right? Look, you got like a whole almost hour to do your homework. And I also have something for extra credit if you want to do it. Okay? So another puzzle.
Oh, I saw that line.
You saw it online?
Yeah.
Okay. It's good. It's a good little puzzle. All right. So now that I do things like this, okay? Now that you have that mastered, Not hardly, since no one got it right. But that's a small one. We'll just move ahead. That's an especially tricky one. Arc sine of -3/4. Did we do one like this? Did we do one like this already?
Yeah.
Oh, I did one like this one. Did I do one like this already?
Yeah.
Oh, okay. So that's... Well, I didn't do one exactly like this. So we're going to go... Which quadrant am I going to draw in? Which quadrant is arc sine -4? 4. So I'm going to draw a picture down here. I'm going to call the opposite side -3. And on purpose, I made this not a 3, 4, 5 triangle. It's a 3 something triangle, right? What does this side have to be?
35.
Is it? 16 minus... No.
The square root is 7.
Square root is 7. Okay? So what's the tangent? What's the tangent of this angle right there? What's the tangent of that angle?
Negative
Yep.
over.
-3 over square root of 7. That's why it's important to give the, put which things are negative and which things are positive. You really want to, you don't want to leave that like that. You want to rationalize it by multiplying by the square root of 7 over the square root of 7. And that comes out to be -3 root of 7 over 7. Okay? And the last one is a u trig. Easy. Okay? U trig. You don't like this? The u trig? So u trig.
Wait, what?
Sine. Let's see who gets it. You can earn valuable prizes. Sine of inverse cosine of -4/5. So you're just going to get this one right. I'll give you a valuable prize if you get it right. Right? I have to pause it for my viewers at home. Okay. Those of you in my viewing audience, inverse cosine is negative in the second quadrant. So we're going to draw a picture in the second quadrant. -4, 5, Pythagorean triple. This side is +3, right? So the sine of this angle is +3 over 5. So that's equal to 3/5. Okay? You get it? They're kind of like little tricky puzzles. They're kind of fun. Okay? So let me go through again. So inverse sine and inverse, so inverse sine of x and inverse tangent of x, okay? Inverse tangent of x. You look for the answers between negative pi over 2 and pi over 2, okay? So you look for, that's their range. That's where you're searching for answers, okay? Cosine, inverse cosine of x, you're looking for answers between 0 and pi radians. So in the first or second quadrant, okay? So you got to know those two ranges of those three ranges. And there are inverse cosecant and inverse secant, but they don't talk about them too much. Okay? So your homework is on my website. I'll show you what it is in a second, if I can find it. Index. And it's right, where are we? Pre-calculus assignments. There it is, chapter 4. I updated it. You have almost 45 minutes to do work. No, you have almost an hour to do work, right? So it is right over, what's today? Friday. Oh, also notice that today is this right here. And then Friday we're doing applications of trig functions, which is just using what you learned to apply them to real life problems and stuff. There's a few in there tonight. But Monday is a review day, and then Tuesday and Wednesday you're going to take a test. Tuesday I think is going to be a shorter calculator part, and mock day, Thursday is going to be the non-calculator part, okay? So you're going to take your second test over Tuesday and block day of next week.
It's gonna take that long.
Well, we're hoping it doesn't take it. We're going to talk again. We might make it so that we want to make sure that
You should
people
just shorten the test.
that people don't come and go, oh, I didn't finish. Can I come back tomorrow after I learn everything? And we don't want that to happen. So you're going to have to finish. And,